the very important chapter, alcohol, phenol, ethers. Look at that. I'm going with that. Listen. And there is alcohol, phenol, and ethers. It's a very important chapter. Discussing this first, we'll go with that aromatic alcohol. Then we can go with that aliphatic alcohol. Then we'll go with the ether. The very important preparation of phenol. What is the method of preparation of phenol? First, we'll go with the Dow's process. What is Dow's process? Let us take, I'm taking benzene. In this benzene, I'm doing that. Already we have discussed electrophilic aromatic substitution reaction. I'm going with that Cl2 with Fe. We got chlorobenzene. In this chlorobenzene, now what I'm going to do as NaOH has high temperature and what is that, high pressure and heating. This mechanism follows benzene mechanism, just keep it in your mind, because introduction of nucleophile to the benzene ring is very tough, but under drastic condition we can introduce taking high temperature, high pressure. Here chlorobenzene is there. Now what I'm going to get as O minus and Na plus sodium phenoxide, hydrolysis H3O plus, which I'm going to get it as, look at that, phenol. So this is the important, this process is called Dow's process. The Dow's process was chlorobenzene converting into phenol, but I am asking you how to get chlorobenzene. Take the benzene, Cl2Fu, Cl2Fe. This is the example of what we can say electrophilic aromatic substitution reaction. How to get benzene? Think about that. You can take CH triple bond CH in presence of iron as what? A red hot tube will get benzene. How to get the ethyne? Think about that. Double dehydrohalogenation of vicinal halide, get ethyne. How to get ethene, or we can say how to get the dibromo halide or vicinal halide? Take ethene, add Br2CCl4. This is what organic chemistry is interlinked. This is the one of the important industrial method of preparation of phenol. This is Dow's process. So next method, the very important method is what from diazonium salts. Please keep it in your mind. I want to say the here important point. The introduction of nucleophile to the aromatic system is very tough, but we can introduce when. The last class we had discussed, what we had discussed, in halobenzene, the minus R group should be present ortho or para position, means you can introduce nucleophile. The another important is you have to make diazonium salts. How to prepare diazonium salts? Look at this. Now I'm taking, listen, I'm taking as, we know that this is benzene, I'm taking systematic way benzene, I'm doing as HNO3, H2SO4. This process we know is called nitration. You are going to get as NO2, nitrobenzene. In this I'm going to use very important reagent, is called the HCl. It's a reducing agent which reduces NO2 into NH2. I'm getting aniline. Look at this, aniline. In this aniline, I'm using as, there is a NaNO2, sodium, NaNO2 sodium nitrite in presence of acidic medium, 0 degrees Celsius. What I'm going to get as, this is N triple bond N plus. This is called diazonium salts. Benzene diazonium salts. It's very important. This is stable at 0 to 5 degrees Celsius. Now in this, we can introduce nucleophile easily. Why? Because this bond is easily breakable, which goes as a N2 gas. So by using diazonium salts, we can prepare the N number of aromatic compounds. That means you can introduce nucleophile system easily in aromatic system. I'm taking, this is diazonium salts. Look at this. What are all the nucleophile can be introduced to the aromatic system? There are 2-3 naming reactions are there. I'm going to explain here. Look at this. Now, I prepare diazonium salts. Repeating again, benzene, nitration, tin HCl, NO2 can reduce NO2 into NH2 is called aniline. When using NaNO2H plus, what is happening? Diazonium salts is produced. Now, look at that. Now, what I am going to do, I prepare prepare diazonium salts, I can say that N2 plus and Cl minus. To this, I am going to add water, H2O, just heating, mild heating, which produces what? Phenol, OH. Why? Because water has, we can write HOH, I can write delta minus and delta plus. It can add easily, and what we can say, N2 leaves. Now, from diazonium salts, we can prepare the halobenzene. How? Look at this. I'm taking. What will be as CuBr. Because this is delta plus, delta minus. Add. I'm going to get bromobenzene. Now, in this add, if I'm going to add CuCl, I am going to get is what? Chlorobenzene. Now, if I'm going to add here as HbF4, heating, I'm going to get as fluorobenzene. And in this, if I'm going to add as Ki, I'm going to get iodobenzene. Look at this. So CuCl, CuBr is example of Son-Meyer's reaction. Now, I'm telling that the importance of the diazonium salts is what? We can able to prepare, or we can say we can introduce the nucleophile to the system of what we can say aromatic. Now here what? Br minus introduced, I minus introduced, Cl minus introduced. I told you that preparation of what we can say the halobenzene is you can prepare from what? Diazonium salts. Or one more thing I want to say in the last class, in aryl halides, the introduction of nucleophile is very tough. So we can introduce when in halobenzene you have to make it as a minus R group, ortho or para position. The other is what? Prepare diazonium salts. Because the OH minus, the introduction of nucleophile to the benzene ring is very tough. It is possible when prepare diazonium salts. That's all. We got the phenol, fluorobenzene, chlorobenzene, iodobenzene, bromobenzene. Over. Now, look at this even, we can say that this is another preparation. The next very, very important preparation is called preparation of phenol from cumene. Look at this. Now, what is cumene? Cumene is called isopropyl benzene. This is called isopropyl benzene. So, how to prepare this isopropyl benzene? Think logically. Take it as benzene. Go with that French-Craft alkylation CH2, CH2, Cl in presence of anhydrous AnCl3. You know the logic because last class we had discussed what is going to form carbocation. Hydrate shift takes place. Then you're going to get cumene is the compound. In cumene, in presence of what we can say hydrogen peroxide, because whenever I'm going to use hydrogen peroxide or light, what is going to form here as a radical mechanism is going to follow, which is going to form as, look at that. This is called the cumene isoperoxide, which is produced. Now, if I hydrolysis, what I'm going to get? I'm going to get the compound of phenol plus I'm going to get as acetone side product. So these are all the important methods of preparation of phenol. First will be Dow's process. Second will be very important from diazonium salts, and third will be is from cumene. So how do you get cumene? Benzene, French-Craft alkylation. Here that carbocation forms, that is hydrate shift takes place, produce the isopropyl carbocation and produces cumene. Then cumene in presence of H2O2 or light we can use it, or air in presence of light you may get cumene isoperoxide. Hydrolysis getting phenol plus acetone. So these are all the three important methods of preparation of phenol. The next is very important is what? The properties of phenol. In properties of phenol, we know that phenol is what? As a plus R group. Look at that. I want to say here, very important method. Look at this. Now, I'm taking phenol. So OH is there. What is OH here? It's a plus R group. Alright, in plus R group means what? It's undergone electrophoresis aromatic substitution reaction. It is a ortho-para director. Why it is ortho-para director? Because here the lone pair of electron is there. The lone pair can take one result, which makes the electron densities more in ortho as well as para position. Therefore, the incoming electrophile attacks ortho or para position. Let us go one by one. First, I am going with that phenol with very important reaction as Br2H2O. Here, Br to H2O, what is going to happen? I am going to get it as OH, Br, Br, and this is Br. What I got as a tribromophenol. So how we got as a here tribromophenol? What is the logic behind this one? Very simple. In water, what will happen? Phenol get ionized. O minus plus H plus. So this is what a stronger plus or group. Therefore, this is going to activate ortho as well as what we can say para position. The bit gives more electron density. In water, phenol gets ionized, which produce phenoxide ion. And Br to water, both undergone what we can say as a disproportionation reaction, produce as HOBr. This is delta minus, delta plus. So this OH minus going to remove H plus ion keep on. When H plus keep on removing that, the more amount of phenoxide ion is produced. And Br plus can attack ortho, para as well as ortho position. How? Look at this. Now, I can take it as O minus, definitely got Br plus. How we get Br plus? Br to water, undergone disproportionation. Therefore, OH minus can remove H plus, equilibrium go towards the forward direction, produce the more amount of phenoxide ion. So now, that's all. I can say this form is called as keto form. In the case of keto form, is not stable. Why? It goes here. It attains aromaticity, which I am going to get as OH, Br. Now the acidic nature of phenol increases. It ionizes faster. Again, this process repeat again. It is going to give Br and Br. Ortho, para, ortho position, getting as a white precipitate. But in the place of Br to water, if I am going to use, look at this again, KBr plus what? KBrO3, I am going to get the what? The same product. How's that? Because Br minus and BrO3 minus is not stable in what we can say acidic medium. Why? They undergone con-proportionation reaction, which produces Br2. That means I can use Br to water. If I am using KBr or KBr plus KBrO3 also produce the same product of tribromophenol. Why? Br minus and BrO3 minus undergone con-proportionation reaction, which produce Br2 plus water. Okay, sir. If I am going to use non-polar solvent like CCl4 or CS2, please keep it in your mind. If I am going to use as a non-polar solvent, phenol never ionizes. Phenol only miscible or soluble. Look at the example. Now, if I am going with that as I am taking as phenol, I am going to use as CS2Br2. So what is going to happen here? I am going to get ortho plus parabromophenol. Why is that? Here the CS2 is a carbon disulfide, or I can use as CCl4. What is going to happen in this case? Phenol is going to miscible or soluble. It never ionizes in non-polar solvent. In water, it is ionizes. That's the reason getting as a tribromophenol. Now here you are going to get it as, I can say OH, Br. I can say here also is one. OH, Br. You know what is the major product? We know that para is major. Ortho is what? Minor product because of steric hindrance. The another interesting. Look at that. Now I am going with that. The next reaction is called, very important reaction is gold-base reaction. What is gold-base reaction? Look at this. Now I am going with that phenol, and I am going to use a CO2 NaOH followed by H3O plus. And because we know that OH is what? Ortho para director, attacks ortho as well as para position. You are going to get it as the compound of, I can say that OH and COOH plus you are going to get is what? OH and COOH. I can say this is called salicylic acid, orthohydroxybenzoic acid, para-hydroxybenzoic acid. I can say that here which is major and I'm using sodium hydroxide, ortho is major, para is minor. Why ortho is major? The reason behind this one, we can say as a intramolecular hydrogen bonding. Yes, I can say that. Intramolecular hydrogen bonding, which makes the ortho isomer is major than para isomer. So how this mechanism takes place? Very simple. Keep it in your mind. Look at that. What I am doing here, that CO2 acts as a electrophile. What is sodium hydroxide? Base. Base always subtract the acidic proton, which forms as O minus. Then I am having is what? C double bond O. Look at this. Now that's all. This step is slow step. You know that. Very simple mechanism. Now this form is called keto form. Enol form is more stable. Why? It attains aromaticity. That's all. O minus. Now if you hydrolysis, you may get what we can say ortho as well as para isomer. They're very important. When I'm taking this orthohydroxybenzoic acid, para-hydroxybenzoic acid, I got it from phenol. The question, how to prepare phenol? Diazonium salts. From diazonium salts getting is phenol, then ask go through the CO2 NaOH, getting ortho and para isomer as a salicylic acid, or we can say orthohydroxybenzoic acid. Yes, we got it. But in exam, what they will ask you, look at that. Now, what they will do, listen. In exam, what they will do, look at this. They may give us, just let us take that. OH. Okay. I can say that just now we have discussed as CO2 NaOH and H3O plus. They will ask you major. We know what is a major product. We got it as of now. We got it as OH and C double bond O OH. Now in this, if I am going to add Br to H2O, it's very important. What are you going to get Br to H2O? Again, tribromo-phenol, CO2 liberates. Br. So how we got orthohydroxybenzoic acid treated with Br to water, what we are going to get as a tribromo-phenol, how we are going to get, what is the logic behind this one? Very simple. Water, carboxylic acid, phenol, both will be ionized. Look at that. This is what the simple logic of mechanism. C double bond O minus. You know that Br to undergone, I told you disproportionation reaction produce HOBr. Therefore, plus here you have that what H plus will be there. Basically is what Br plus attacks. Look at this. To attain aromaticity, look at the CO2 leaves. That's all. We got as this is the mechanism. This is what the reaction taking place when the orthohydroxybenzoic acid treated with Br to water. Even you can use Br minus and BrO3 minus also produce same product. And look at this one more important. Now, listen. Now same thing. And I'm going to use as now very simple. I'm going to use as sulfuric acid, HTSO4. This process is called sulfonation. In sulfonation, what you are going to get as OH, SO3H plus you can say that OH, SO3H. You can say, please keep it on your mind. Low temperature, ortho favor, high temperature, para is favor. Now in this, if I am going to add as Br to H2O, very simple. What is that? Desulfonation takes place. Do you remember last class? I told you that. When, what you can say, sulfonation reversible process. In this, if I am going to add water, desulfonation takes place. Water is there, SO3H will go. Now Br to water, phenol, what are you going to get it as? That's all. This is the logic of the question. This is the very important, the method of what we can say, getting tribromophenol. Not only what we can say, phenol, we can say that orthohydroxybenzoic acid gives tribromophenol treated with Br to water. Para-hydroxybenzoic acid also gives tribromophenol treated with Br to water. Even para-hydroxybenzene sulfonic acid, orthohydroxybenzene sulfonic acid treated with Br to water end up with tribromophenol. Why? Because SO3H means what? Desulfonation takes place in presence of water. Are you able to follow what I am trying to say? This is what in the examination point of view they will ask. You should be very clear. Now, next will be a very another easy reaction which I want to say that. Look at that. In this. Now, next one. I am going with the next is the Riemann-Diemann reaction. And I am taking as not Riemann-Diemann. One more very important process is there. I want to say that. Here as OH I am taking, you know that this is salicylic acid. In salicylic acid, I am going to add as CH3, C double bond O, O, C double bond O, CH3. What is this called? Acetic anhydride. In acetic anhydride, in presence of acidic medium, if I am going to heat this, it's a esterification reaction takes place. Here the lone pair attacks here, the bond breaks. What we are going to get as is called acetyl salicylic acid, called aspirin. Can say it's called aspirin, acetyl salicylic acid, which is used for what we can say the many of the heart patients will take aspirin. The role of aspirin is what it's reduced fever also. At the same time, we can say the heart patients the blood will be very what we can say very thick. When you take this, it becomes very thin. The flow blood will be heart will be easier. Many of the heart patients will take tablet aspirin. There's a preparation of aspirin. How to prepare salicylic acid? Phenol plus CO2 and NaOH. How to prepare phenol? Dow's process. Dow's process means a chlorobenzene. How to prepare chlorobenzene? You know that benzene plus FeCl2 or AlCl3Cl2 halogenation of benzene is called electrophilic aromatic substitution reaction. So this is what they may ask in the JEE mains question. They may interlinked. Organic chemistry is always is what? Interlinked. The next will be. Look at that. I am going with that, listen carefully. Next is, we know the Riemann-Diemann reaction. I am taking as phenol. I can go with that NaOH. You see, don't forget CHCl3, chloroform. Here, what is going to form? Dichlorocarbon as the electrophile. It's a neutral electrophile. CCl2. It's called dichlorocarbon. Now, what is going to happen in this? Now, it will be getting same thing. OH, C double bond OH is called orthohydroxybenzaldehyde. Plus, we can say that para-hydroxybenzaldehyde. The major is what? Ortho, due to hydrogen bonding. This is minor. This is very important. Orthohydroxybenzaldehyde and para-hydroxybenzaldehyde. Look at that. Next will be now. So we have discussed one by one. Preparation of phenol is over. In properties, one is bromine in water and bromine in CCl4, bromine in CS2. CS2 means carbon disulfide. In that, why is there in bromine in water getting tribromophenol? In bromine in CS2 or carbon disulfide or CCl4, we are getting as a ortho or para isomer. What is the reason? Because in water, phenol gets ionizes. It gives H plus Ion. But in CCl4 or CS2, it never ionizes. It's only miscible. Then Riemann-Diemann reaction, orthohydroxybenzoic acid and para-hydroxybenzoic acid. In the gold-based reaction, in Riemann-Diemann reaction, we are getting as a orthohydroxybenzaldehyde para-hydroxybenzaldehyde. Ortho is made due to what? Intramolecular H bonding. Over. Now aspirin preparation is over. Next is, now come to the point. The case of nitration. Look at this in exam. In nitration, look at this. I'm taking phenol. I'm using dilute HNO3. When dilute HNO3, what is going to happen? Which I am going to get it as OH NO2 plus we are going to get as OH NO2. Same thing. Here ortho is major at room temperature or lower temperature. Para is major at high temperature. But here what they will ask the question: ortho nitrophenol, para nitrophenol, which is more acidic. Very important. Ortho nitrophenol is less acidic than para nitrophenol. Why? Here one is plus hydrogen bonding. So I can say that this is 1, this is 2. We can write that pKa of 1 is greater than what we can say that pKa of 2. So why? So this is 1, this is 2. Am I right? That means the pKa of orthonitrophenol is higher than para-nitrophenol. Why? Lower pKa strong acid. They may ask you statement wise. They may give the reaction. Another important, and I am going to take it as con HNO3 concentrated H2SO4. So what you are going to get as very strongest acid is called picric acid. So why? Please understand. Phenol does not react with bicarbonate solution, but picric acid is it. And I'm going to add here NaHCO3. What happens? CO2 liberates. Here that O minus and Na plus. Here is NO2. 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 CO2 comes out. But here NaHCO3. No reaction. Why picric acid react with bicarbonate solution? Because it's the very strongest acid. pK is 0.69. You can say 0.6. Very strong. It's strong acid than orthohydroxybenzoic acid. It's strong acid than orthonitrobenzoic acid. It's strong acid than acetic acid. Why pK is 0.69? It reacts with sodium bicarbonate, liberate CO2. Very strongest acid this is in organic acid. Now, next, so we have learned about what we can say phenol. Now come to the point. We have discussed phenol. In the preparation of phenol is over, and properties of phenol is over. Now we'll go with that alcohol, aliphatic alcohol. Very important in aliphatic alcohol. Preparation of aliphatic alcohol. How to prepare? First is using Grignard reagent. What is Grignard reagent? How they are going to prepare? Let us take a simple example. I'm taking CH3Cl. I'm taking alkyl halide. In presence of, I'm taking is what? Mg ether. We should not use moisture solvent. Moisture is present, Grignard reagent gets spoiled. Look at this. I can say this is delta plus, this is delta minus. When I'm introducing magnesium between CH3 MgCl, I can say this is delta minus, this is delta plus. This bond is easily breakable. This bond is C bond. Mg is called organometallic bond or organometallic compounds. Why? Because delta minus, this bond is easily breakable, this tough to break. And we have to use ether as a solvent. If you are going to use alcohol, if you are going to use water, what will happen? Grignard reagent gets spoiled. Why? Because if I am going to use water, H2O is there. What is going to happen? This is CH3 minus. Therefore, the H plus come from water, attacks. What is going to hit? CH4 gas liberated. Even if you are going to use as a alcohol also, alcohol, CH3OH is there. The H plus come from alcohol, which react with Grignard reagent, liberates CH4 gas. That's the reason Grignard reagent gets spoiled in presence of moisture. If you use dry ether, Grignard reagent is inert. it never react with ether. That's the reason we are using for ether as a solvent or THF as a solvent. So what is the synthetic utility of Grignard reagent? By using Grignard reagent, we can able to prepare primary alcohol, secondary alcohol, tertiary alcohol. Look at this. That's an example of nucleophilic addition reaction for carbonyl compounds. We'll discuss now. Look at that. Now, I can say, as I'm taking, first I'll take as HC double bond OH plus I'm taking is what? CH3 MgBr. Now, I can say this is delta plus, this is what? Delta minus. Therefore, this is what? Delta minus, this is what? Delta plus, this is also delta minus. Now, what will happen? Attacks, bond breaks. Now, what I am going to get? H, C, H. We can write as here O minus NgBr. Now, CH3 is added. Now, hydrolysis H3O plus. And got it as CH3, CH2, OH. For methyl magnesium bromide, formaldehyde, I got ethanol. Now I'm taking in the place of H, I introduce this what CH3 as C double bond OH. It's called acetaldehyde. I'm using same reagent of CH3 MgBr. CH3 MgBr. I can say this is delta minus. I can say this is delta plus, delta minus. This is nucleophile. This is electrophile center attacks. Therefore, what we can say, the nucleophile is added to the carbonyl compound is example of nucleophilic addition. That is, I can say as H3O plus. What I am going to get as CH3 as CH, OH and CH3. I got secondary alcohol, formaldehyde, primary alcohol, acetaldehyde, secondary alcohol. If I am going to use ketone, same thing I am using as CH3 MgBr. I can say delta minus, delta plus attacks, bond breaks, and followed by H3O plus. What I am going to get as CH3, C, CH3, CH3, OH. I got, look at this, by preparation of aliphatic alcohol by using Grignard reagent. One will be use what? Formaldehyde, acetaldehyde, acetone. When I am using the Grignard reagent of methyl magnesium bromide, if I am using formaldehyde, end up with primary alcohol, acetaldehyde, secondary alcohol, acetone, tertiary alcohol. Even if you use ester, if I am going to use excess of Grignard reagent, end up with tertiary alcohol. Look at the example. Look at the example. Now, I can say that. Listen. I'll take it as CH3. Very simple example. C double bond O, CH3 I am taking. I'm going to use a CH3 MgBr. Simple mechanism. Obviously, what? This is delta plus, delta minus. This is what? Delta minus, carbon, oxygen. We can say that oxygen is most electronegative than carbon. Therefore, this nucleophile attacks. Therefore, the bond is going to break. You are going to get it as CH3 again. I can break like this. C double bond O, CH3. And I'm going to use this one more. Again, if I use Grignard reagent as CH3 MgBr, I can say this is delta minus. Attacks away on breaks. Now what I am going to get followed by H3O plus. What I am going to get as CH3 as CH, CH3, OH, CH3. I got tertiary alcohol. That means from Grignard reagent, we can able to prepare aliphatic alcohol. If you want to use formaldehyde, use formaldehyde with the Grignard reagent, primary, acetaldehyde, secondary. In ester, tertiary alcohol. If you are going to use formate, ethyl formate, propyl formate, butyl formate, if you are going to use, end up with secondary alcohol. Look at that. That's very important. This is formate. I can take it as this example, C double bond O, CH3. I can say this is methyl formate. When methyl formate, then I'm going to use that excess of CH3 MgBr. Look at the mechanism. Now, delta minus attacks, bond breaks. What I get as CH3, CHO. This is called acetaldehyde. Then we have discussed acetaldehyde. Acetaldehyde with excess of not reagent end up with this what? Secondary alcohol. So in ester, we cannot say all ester on treated with excess of Grignard reagent gives tertiary alcohol. No. If I am going to use methyl formate, gives secondary alcohol. So please keep it in your mind. If formate ester treated with excess of Grignard reagent end up with secondary alcohol. Now, next to me, very very important now. We can able to prepare. We can say as another preparation of alcohol by using reducing agent. So what reducing agent? There are two types of reducing agent. One is called lithium aluminum hydrate. Another one is called sodium borohydrate. What is reducing agent? Which donate H minus ion. Let us take carbonyl compounds. I can take it as CH3, C, double bond O, CH2, CH3 I'm taking. It's a ketone. I'm going to use as a sodium borohydrate, NaBH4. So it's a reducing agent. So what is the role of sodium borohydrate? It gives H minus ion. It gives H minus donor. Look at this. Very simple. H minus coming from where? Sodium borohydrate. Attacks here. Bond breaks. Or you are going to get as CH3 as CO minus H CH2 CH3. Then hydrolysis H plus. Or I am going to get as CH3 as CH OH and what? CH2 CH3. Please understand. There is an observation here. What is produced? Hydrogen compound. This is double bond O, sp2 carbon, planar. Therefore, H minus attack front as well as backside. I end up with racemic mixture. This is what observation in what we can say the reduction of sodium borohydrate, especially for ketones. Once it reduce the alcohol as a chiral, end up with racemic mixture. Even we can say that means ketone gives secondary alcohol. Suppose if I am going to take it as what? CH3, CH2 as C double bond O H by using what? Sodium borohydrate, NaBH4. Or I'm going to get as CH3, CH2, CH2 OH. Observe that. CHO becomes CH2OH by using sodium borohydrate. Sodium borohydrate never reduce carbon-carbon double bond. Sodium borohydrate never reduce carbon-carbon triple bond. Even lithium aluminum hydrate never reduce carbon-carbon double bond as well as carbon-carbon triple bond. It reduces, we can say, carbonyl compound into alcohol, carboxylic acid into alcohol. But sodium borohydrate does not reduce ester. Sodium borohydrate does not reduce carboxylic acid. Look at that. In exam, what they will ask. Listen carefully. Now, when I'm taking as CH3, C double bond O, CH2, CH3, and I'm going to use as LaH. What is this? LaH is called lithium aluminum hydride. Now, obviously H minus comes from where? Lithium aluminum hydride. So we can write as LiAlH4. H minus attacks, therefore bond breaks. Afterward, we can say hydrolysis. We can write as CH3, CH, OH, what? CH2, CH3. Even that lithium aluminum hydrate can reduce carbonyl compound into an alcohol. Even lithium aluminum hydrate reduces ester into alcohol. Lithium aluminum hydrate reduces carboxylic acid into alcohol. Look at the example. Now I'm taking CH3, CH2. You can say that C double bond O, O, CH3. Very simple. I'm taking this LaH. What is LaH? Lithium aluminum hydrate. What is the reducing agent? It donates what we can say H minus ion. Look at this H minus ion coming from LaH. Attacks, bond breaks. What I got? CH3. CH2, I got C double bond O H as an intermediate. We know that lithium aluminum hydride is strong reducing agent. It reduces further aldehyde into what? That's all. Please keep it in your mind. That means, how that lithium aluminum hydride react with ester. In that C, what we can say, this bond is going to break. This becomes what? CH2OH, and remaining part is what? Another alcohol. I'm getting as OH. Fine. Now look at that. Next will be. Now, in exam, what they will ask? Even the carbonyl compounds can be reduced by using nickel hydrogen. In exam, what they will ask you? Look at that. Listen, when I am taking, they will ask you yes, NaBH4. What will happen? Sodium borohydrate. Please keep it in your mind. Double bond O. Here what? See, double bonds is there. This never reduce. Sodium borohydrate does not reduce carbon-carbon double bond. What you are going to get as? That's all. Suppose if I am going to use as nickel hydrogen, what happens? Double bond also get reduced. See, double bond also get reduced. Will be end up with OH. Here double bond is not reduced. When I am using sodium borohydrate, when I am using nickel hydrogen, what I am going to get? Double bond also get reduced as well as keto group also get reduced. That's all. And one more example, look at this. And I am going to take, can you answer this one? Now, I can say that as CH3, C double bond O, and again CH2, and again CH2, as C double bond O, what CH3. I am using as, one of these what? Sodium borohydrate. Another one is what? LaH. So, when I am using this compound, when I am going to use sodium borohydrate never reduce ester. I am going to get the compound of is what? CH3, CH, OH, CH2, CH2, COOMe. But in the case of lithium aluminum hydrate, it reduces ester as well as what? Carbonyl compound. What I am going to get as CH3, CH, OH, CH2, 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 OH. That's all. This is what in the examination point of view they will ask. Now we'll go with the some, what we can say, the properties of alcohol. We have learned just now. Preparation of alcohol we have discussed. Even we can say hydroboration oxidation. Preparation of alcohol we discuss in alkane. That means alkenes. We can say oxymercuration, demercuration. Preparation of alcohol. Yes, we have discussed. These are all the other method of preparation of alcohol. Now come to the point. Next will be, as I'm going with that. Now the properties of alcohol. In properties of alcohol, first we'll be going with alcohol reacted with very simple example, CH3, CH2OH. I'm going to use is what? EBr3 phosphorus dibromide using DMF solvent. This follows a SN2 mechanism. We'll be getting as CH3, CH2, Br. Now, if I'm going to use CH3, CH2, OH using SOCl2, thionyl chloride, what is going to happen? I'm going to get the compound of CH3 as CH2Cl. This is best method preparation of what we can say alkyl halide. Why? Because the side product I'm going to get SO2 as well as HCl liberate as a gas. I'm getting pure compound. Even I can use as CH3, CH2, OH using PCl5. What I'm going to get as CH3, CH2, Cl. This is very important. Preparation of what we can say alkyl halide from alcohol. We can say the property of alcohol, we can say preparation of alkyl halide. Therefore, alkyl halide, aryl halide, alcohol, phenol, both are interrelated. So this follows SN2 mechanism, phosphorus tribromide. Fine. Next, very important, Lucas test. That means the distinguish between primary, secondary, and tertiary alcohol. Distinguish between primary, secondary, and tertiary alcohol at room temperature. Look at this. I am taking primary alcohol. CH3, CH2, OH. What is Lucas reagent? ZnCl2. I can write anhydrous and concentrated HCl. No reaction at RT. RT means what? Room temperature. Now I'm taking secondary alcohol, CH3, CHOH, and CH3. Now what we can say? Same thing, Lucas reagent, anhydrous ZnCl2. I can take it what? Con HCl. I'm going to get CH3, CHCl, CH3. It forms what we can say as precipitate or turbidity after 10 minutes. After 10 minutes. Now I am working tertiary alcohol. By using Lucas reagent, the reaction goes very fast. It forms turbidity immediately. On HCl. What is going to happen? Look at this. Why it forms immediately? Reason is what? Formation of the bond is going to break here, produces tertiary carbocation. Because of it follows SN1 mechanism, it goes faster. Produce tertiary carbocation. That's the reason immediately forming turbidity as tertiary halide. But in the case of why secondary halide forms after 10 minutes, because here the bond breaks, forms what we can say as secondary carbocation. It's less stable than tertiary carbocation. Therefore, the secondary halide forms after 10 minutes, which gives us a turbidity. But this carbocation is not stable at room temperature. That's the reason primary, secondary, tertiary alcohol can be distinguished by using Lucas reagent. Primary does not react at room temperature. Secondary form turbidity after 10 minutes. Tertiary immediately can form because of formation of tertiary carbocation. That's all. And next is oxidation of alcohol. Very important. Oxidation of alcohol. Oxidation of alcohol. Look at this. Now taking very simple as CH3, CH2, CH2, OH I'm taking. It's a primary alcohol. When I'm going to use very important reagent, it's called PCC. What is this PCC? Pyridinium chlorochromate. It's a special reagent. It's conversion of primary alcohol into aldehyde. Like this. I can say that as CH3, CH2. I can say that C double bond OH. But if I'm going to use as here CrO3, what is CrO3? It's a chromium trioxide. What happened? Primary alcohol is converting into carboxylic acid. But what about CrO3 for secondary alcohol? That's all. Ketone. For CrO3, acidic medium, you are going to get as a ketone. For secondary alcohol, for primary alcohol, use carboxylic acid. For PCC, pyridinium chlorochromate, use aldehyde for primary alcohol. So what is the condition of oxidation of alcohol? Very important. In alcohol, alpha carbon having hydrogen. Alpha carbon having what? Hydrogen. If hydrogen is there in alpha carbon, oxidation takes place. That's the reason tertiary alcohol never undergone oxidation because no alpha carbon. No alpha hydrogen. Sorry. Now I can see that. Look at this example. Now this is alcohol. This is what we can say alpha carbon, no hydrogen. That's the reason tertiary alcohol never undergone oxidation by using oxidizing agent of PCC, or we can say CrO3. Tertiary alcohol never undergone oxidation. This is what the properties of what we can say that aliphatic alcohol. Now can you go on question how IIT is expecting from you? Look at that. In exam, what they will expect from IIT. Look at this, I am taking hex 3-ine 1-al. Then going to use as one will be NaBH4 and second will be is what PBr3 as a major. Now next will be I am going to use carefully magnesium ether. In that I am going to use as HC double bond OH. And third will be I am going to use palladium, barium, sulfate. Okay, I can look about H2. So how we have to solve this question? This is very important. Hex 3-ine 1-al. So write the structure. Look at this. CH3, CH2, C triple bond C. I can write CH2, C double bond OH. Now 1, 2, 3, 4, 5, 6. Hex 3-ine 1-al. What is sodium borohydride does it? It's a reducing agent. It reduces CHO into what? CH2OH. I told you sodium borohydride does not reduce carbon-carbon triple bond as well as double bond. It reduces CHO group. Now what I am going to get as? I will be getting as CH2OH when I am going to use as sodium borohydride. The next will be is what? Phosphorus tribromide. What is going to happen? Here the OH is there. The OH becomes what? Br. This is A. Now Mg, can you say this is alkyl halide? Magnesium, what is going to happen? There is a Grignard reagent is going to form. This is A. Now this react with Mg. What we are going to get it as? We'll be getting as this is A, CH3, CH2, C triple bond C. I can write that CH2, CH2 Br. This is A. When react with Mg, what is going to form as MgBr? This is delta minus, delta plus. Now react with formaldehyde. What is going to happen? CH2 minus attacking the carbonyl carbon, which forms one more carbon is going to be added. I am going to get it as CH3, CH2, C triple bond C. I can say that CH2 1, 2, 3, 4, 5 CH2. I can write that CH2OH. Now what I am using palladium, barium, sulfate, hydrogen is called Lindlar catalyst. So triple bond becomes what as double bond as a what alkene I am going to get as cis alkene. This is the answer of the question. This is what JEE mains would expect. Look at this: sodium borohydride, phosphorus tribromide, Grignard reagent, then Grignard react with carbonyl compound, then palladium, barium, sulfate. This is how they will ask in the examination point of view. You should be very careful. Can you go one more question linked with the electrophilic aromatic substitution reaction? Look at the reaction. Look at the question JEE mains, how they would expect from you. Listen. You can take it as listen. Very simple question. Look at that. I'm taking listen. One, two, three, OH. Okay, in this OH, I am taking as there will be is what? 4CH3 is there. I am taking. Now, when I am going with that as CrO3. What is CrO3? It's a oxidizing agent. It oxidizes primary alcohol into what? Carboxylic acid. So I am taking like this. Here will be is what? OCH3. Now what I am going to get as CH2, CH2. So I can say 1, 2, 3, 1, 2, C double bond O, OH. I got as a carboxylic acid. Fine. Now what I am going to do? In this, I am going to take it as H2SO4. What is H2SO4? It's a dehydrating agent. What will happen? It is going to accept H plus. Once accept H plus, look at this. Now I can write it as, even I can use rather than H2SO4, it's better to use as, I'm using as H3PO4. H3 for better dehydrating agent. Now what is going to happen? Look at that. As OCH3, I can write it as CH2. I can write as CH2. I can write that C double bond O. I can write that O. I can write it as H and H plus. Now the bond is going to break, which produces a stable carbocation. I can write it as OCH3, as CH2, CH2, C double bond O plus. Now this is going to attack here, which produce, you may get as the compound of, I can give the number 1, 2, 3, 4, 5. Now what is going to form as a 5-member ring as double bond O. Now give the number again 1, 2, 3, 4, 5. It forms 5-member ring. Look at that. This is what the answer. This is what the answer. This is what you may expect for the JEE mains question. It's a major product they will ask. Look at this. It's a alcohol, right? The alcohol, I can say 1, 2, 3. Alcohol by using CrO3. Primary alcohol get what we can say oxidized, which gives carboxylic acid. Then H3PO4 cyclization takes place. Why H3PO4 is a dehydrating agent, gives H plus formation of stable carbocation. Electrophilic aromatic substitution reaction takes place. Here I can say as here OCH3 is missed. This is what in the examination point of view they will ask you. This is what in the examination point of view for JEE mains. Can you go one more question? Last question, then we can go for ether. Look at this. Now, I'm taking as one question. Listen. I'm taking as same thing as I'm taking as OCH3. Now, in presence of, look at this. It's called the succinic anhydride. When succinic anhydride, I'm using as, listen carefully, anhydrous AlCl3. We know that we discussed already. We can ortho, meta, para. Therefore, electrophilic aromatic substitution reaction takes place. You may get the compound of this. I can say ortho, meta, para. What I got as C double bond O. I can take it as CH2, CH2. I can take it as C double bond O, OH. Now I am using here as zinc amalgam, HCl. What is the reaction is called? It's example of Williamson reduction. This becomes what reduced as CH2. Look at that. As OCH3, I am taking as CH2, as CH2, as CH2, as C double bond O, OH. Now again, if I am going to use as concentrated H3PO4, what is going to happen? Here H is there, water molecule is removed by using H3PO4. Cyclization takes place 1, 2, 3, 4, 5, 6 number carbon. I am going to get it as double bond O as OCH3. That's all. This is what an examination expected. Succinic anhydride, example of what we can say, Friedel-Crafts acetylation, zinc amalgam, cyclization. So these type of questions you may expect in JEE mains examination. This is what I am telling to you. Next is put the heading ether. The very important method of preparation ether is Williamson ether synthesis. So what is Williamson ether synthesis? It follows SN2 mechanism. It follows SN2 mechanism. Look at that. I'm going with that. Let us take CH3 Br plus I am taking is what? CH3, CH2, O minus. Now alkyl halide, this is what? Alkoxide ion. It follows SN2 mechanism. Is example of what we can say? Williamson ether synthesis. I am writing that. Williamson ether synthesis. Therefore attacks backside of the carbon. Bond breaks. Now what is I am going to get it? CH3, O, CH2, CH3. Even we can prepare for aromatic ether. Taking is what? Phenol. And taking is what? Phenol. If I am using sodium hydroxide, NaOH. I am using here is what? CH3I. Now what? First acid-base reaction forms as sodium phenoxide. Now I am going to use a CH3I. Attacks, bond breaks. I am going to get as CH3. But very in this, the drawbacks of Williamson ether synthesis. If I am going to take secondary or tertiary alkyl halide, end up with alkene. Why? Here, this is base as well as nucleophile. When I am going to take it as a secondary or tertiary halide, end up with elimination product. Look at the example. Now, when I am going to take it as, that's a drawback of Williamson ether synthesis. When I am going to take, look at this, see, and I am taking as CH3 as C, Br, I am taking here H, and here is what? CH3. And I am going to use as same thing, ETO minus. What is going to happen? As ETO minus ethoxide ion, base. Now, here there are what? Two bulky substituents are there. Therefore, the nucleophile cannot attack backside of the carbon. So, rather than substitution, what takes place? Elimination. What is the condition of elimination? Alpha, beta. So, beta carbon having hydrogen. Therefore, what is going to happen? Easily here, this is ETO minus. Means ethoxide ion is act as a what? Base. So, base is going to abstract the proton. Bond comes here and this is breaks, which forms as CH3, CH, double bond, CH2. This is major. Now if I am going to take as CH3 as C, CH3, CH3, Br, definitely what? Tertiary halide, 100% elimination. Heating favors elimination. Now I can write that CH3O minus. Here substitution is not possible. Why? There is a bulky substituents are there. Therefore, nucleophile cannot attack backside of the carbon. Therefore, end up with is what? Elimination. That's all. In exam, what they will ask you, that's very important. Look at this. In exam, look at the exam in what they will ask you as. Yeah, this is one. Yeah, look at this bulky base. But here, what is ethyl halide? So here, what takes place? Substitution. Here, what takes place? Elimination. Why? What is the logic behind this? Base, but tertiary halide undergone elimination because no space to attack backside of the carbon. Therefore, here what takes place? Elimination, giving us a product of here substitution as a major product. Bond breaks, getting us. That's all. That means what I'm trying to say. In Williamson ether synthesis, alkyl halide always primary, you may get ether as the product. If you are taking secondary or tertiary halide, the major is elimination product. And next very important properties of ether is cleavage. So ether can be cleaved by using HI. The HI is a strong acid it can able to break the, what we can say that ROR bond easily by using the strong acid. Then in that there are two cases are there. If it is unsymmetrical simple ethers follows SN2 mechanism. Unsymmetrical bulky ethers follows SN1 mechanism. Look at the cases. There are two cases. I'm going one by one. Listen. I'm going. Look at this. I'm taking a CH3, CH2, O, CH3. I'm taking. This is unsymmetrical simple ethers by using what HI. This follows SN2 mechanism. How? Similar to SN2 mechanism. How? Here the lone pair is there. Lone pair takes place H plus, I minus leaves. Now I can write CH3. I can write that CH2. O. I can write as CH3. Here is what H. Here is what plus. Now look at this. I minus has to attack the backside of the carbon, whether this carbon is less hindered or this carbon is less hindered. I can say this carbon is less hindered. So therefore, I minus attacks, bond breaks. So what you are going to get as will be CH3, CH2, OH plus CH3 high. And what about if it is bulky unsymmetrical ether? So therefore this follows SN2. If it is bulky unsymmetrical ether follows SN1. Look at this. And I'm taking as CH3C, CH3, CH3, O, C, H. I'm taking as CH3, CH3. This is bulky unsymmetrical ether. Same thing I'm using as H plus. Here that lone pair of electron is there. Attacks. So I can write that CH3. Here is what CH3. I can write here is CH3 and write OH. Here is positive charge. I can write CH. I can write CH3. Here is CH3. Now I minus cannot able to attack any of the backside of the carbon. Why? All these two carbons are highly hindered. So now what is going to happen? Bond breaking process. And bond breaking process, which is going to produce stable carbocation, we have to see. Once if the bond is going to break, look at that, it produces the stable carbocation. Tertiary carbocation is produced, which I am going to get as CH3, as here is CH3, here is also CH3, here is positive charge, plus I am going to get as CH3, CH, OH and CH3. Now I minus attacks, I am going to get as I. That's all. Please keep it in your mind. Bulky unsymmetrical ether, HI cleavage followed by SN1. Simple unsymmetrical ether follows SN2 mechanism. But in exam, what they will ask you, listen. As an exam, this is 2018 JEE mains question. They asked, how many of you going to get the answer? Listen carefully. Look at that. This is what they asked in the exam. Look at this. Now what I am trying to say, this is going to follow how the reaction is going to take place. So this part I can say you cannot break this bond easily. Alright. So in this case, when I'm going to use SHI, look at this. Obviously here the bond is going to break. In this case, please understand the stable carbocation. When I'm going to break this bond, produce a stable carbocation. So I'm going to get the compound of, look at this. OH. This is what we got the answer. So when it's going to attack here, what is that as H plus bulky unsymmetrical ether. Bulky unsymmetrical ethers follows SN1. Here this bond easily breakable because we cannot break the bond easily, going to get as a OH and CHI CH3. This is what I should mention. This is excess, better to mention as excess. This is what JEE mains of 2018 question. Major. That's all. Now we'll discuss some good questions of how the organic chemistry is interlinked with everything. Look at this. We'll go on question. The question gives more and more confidence. Look at this. Can you find out? I'll take it as one by one. I'll go. Listen. First will be. And before going this, just I want to say as the chemical test distinguish between phenol and ether. That means aromatic ether. Phenol react with neutral FeCl3 produce violet color. Phenol never give Lucas test. Right. Ether never react with neutral ferrichloride solution. That's all. Just keep it in your mind. Now come to the point. Let us take this compound. I am going with that as C triple bond CH. I am using as vanadium, barium sulfate, H2A, right? B2H6, H2O2 OH minus, B, use ECC, C. Now here I am going with that as what will be NaNH2. 2 will be as we are taking as CH3, that is D, and I am going to use as Lindlar's catalyst. That's E. I'm going to use NBS. NBS, I'm going to use it as 1 mole. As NBS means N-bromosuccinamide. F major. Just I'm given the question for this. This type of questions you may expect for the JEE mains generally. Now I have taken phenolacetylene. What is the role of palladium barium sulfate? We know that palladium barium sulfate is it's a Lindlar catalyst. Alkyne becomes what alkene. I'm writing CH double bond CH2. And I'm going to use B2H6H2O2OH minus. What does it? It's a hydroboration oxidation. That means we can say boron is going to always attack it. Therefore, this becomes CH2OH. Here H is going to come. I'm going to get as phenyl ethanol. CH2, CH2OH. What is PCC? Pyridinium chlorochromate. I'll be getting as OH. That's all. Over. And here you see that what is NaNH2? Base. Always base is going to abstract the proton, which forms as C triple bond C minus. Attacks the backside of the carbon, follows SN2. Bond breaks. That is D. Which I'm going to get C triple bond C CH3. What Lindlar catalyst does it? Triple bond become, that means double bond cis alkene. Very important. That means I'll go with, okay, fine. HCH. Now we are going to use NBS. NBS is for what we can say allylic and benzylic substitution. This is allylic carbon, it's a stable radical. That's all. So you may get the product of FS will be because NBS is a reagent is only for allylic and benzylic substitution. This I can say is a allylic carbon. Therefore, the Br is substituted. Right? So this is the product of F. Right? Now, so can we go one more question? I'm going to give a big synthesis process. Listen carefully. OH, H3PO4. A. Next, we are going with as Br2, CCl4 is B. B with NaNH2, 2 more C. C with red hard iron, we will get this D. D we are going with as HNO3, H2SO4. We are going with as E. E we are going with as FeBr2, heating as F. F we are going with as tin HCl. Tin HCl, what we can say, F become or A, B, C, D, E, and F, and this will be G. Right, and G we are going with as, again G will be tin HCl, I can go with that NaNO2, HCl, G and H, and H become, very important, I am going to with as H2O, H2O heating, G, H, I can say I am going with here will be as Br2, H2O. So very, I have taken that is J, and take it as here excess. So A, B, C, D, E, F, G, H, I, J. Find out J is a major product. So this is what in the examination we expect that. Look at that. We know that this is dehydration of alcohol. Look at this. I can take it as CH2 double bond CH2. This is what we know that alkene decolorizes bromine in CCl4. Dibromo vinyl halide CH2Br. I can write that CH2Br. Then 2 mole of NaNH2 base. This gives us the alkyne C triple bond CH. This is H. Then iron, that hard cube. D, what you are going to get? D is must be benzene. So D is what? Benzene. Then benzene, HNO3, H2SO4, that is nothing but E. E is nothing but nitrobenzene. NO2. In nitrobenzene, look at this. I am using FeBr2. NO2 is what? Minus R group. Then minus R means deactivating benzene ring. They are meta director. So FeBr2, F is nothing but as NO2. This will be what? Br. Very interesting. Listen. Now, tin HCl. What tin HCl does it? F, NO2. NO2 becomes NH2. So I can say G must be as, I can say as NH2 Br. Now I can say as, now NaNO2 HCl, NH2 becomes what? As N2, and this will be Br. Now H2O heating, what are you going to get as OH Br. It's very important. Br to water excess. Obviously, what gives tetrabromophenols? So J will be is what? J is OH Br, 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 This is what in the examination they will ask you. This is what the JEE mains question. Look at this, how it's all the inorganic, that means all organic will be interrelated. Dehydration of alcohol. This is addition of alkene. This is again the preparation of alkyne, preparation of benzene, electrophilic aromatic substitution reaction. This is also electrophilic aromatic substitution reaction. This is reduction process, diazonium salts, preparation of phenol, properties of phenol. So this is how that the organic chemistry is interlinked. So you should understand. So I hope you'll be understanding the organic chemistry. The remaining part will be discussed next class. I'll give one more question. I discuss one more question. Is that? So be ready with that. I want to give you one more question. Listen. Look at that. We'll go with one more question. Listen. I'm taking as same logic will go as CH3, C triple bond, CH. Taking here I'm using CH3 MgBr. So what will happen? I'll go one by one. I'm taking this. So this is what acidic hydrogen. This is I can write delta minus delta plus. This also is what delta minus delta plus. What is here? Not reason would act as a base. Base would abstract this proton. Now this is CH3 C triple bond C. I can write as MgBr. I can write this is what delta minus. This is what delta plus. Now in this, if I am going to use as H C double bond OH. Now this acts as a what? Grignard reagent. Formaldehyde attacks. Now this is going to break. Now what I am going to get as CH3 C triple bond C. I can write as CH2OH followed by H3O plus mild. Now I can write it as, I can go with as Lindlar's catalyst, palladium, barium sulfate, H2. So what is the role here? I can say it's going to follow as a cis alkene. We'll be getting as CH3, C double bond C, H, H, and CH2H. You may expect these type of questions. One more question I'll discuss finally. Very interesting. Can you? It's a very important question. Listen carefully. Listen. Now I'll go with that. CH2OH, CH2, C triple bond CH. Look at that. 1 NaNH2. You can go with that 2 more. Second will be CH3I, 1 equivalent. And third will be as CH3, CH2I as a 1 equivalent. And last will be as fourth one. It will be palladium, barium sulfate, H2. I can give as a X as a major. It's a very important question. Now this is the base. This is also acidic proton. This also is for acidic proton. So anyway, using 2 more. So both will be what we can say. Now this is very important. So whether CH3I can react with this or CH3I can react with this. Please keep it in your mind. So the carbon is better nucleophile than oxygen. So therefore CH3I going to react here. That means this attacks. Now this is going to, next step will be this is going to attack here, which we are going to get it as O, as CH2, CH3. I can write as CH2, CH2, C triple bond C, CH3. If you put reverse, your answer is incorrect. This is what IIT would expect. JEE means will expect. Now, palladium, barium sulfate, H2, it's a Lindlar catalyst. So what is going to happen? Observe carefully. Double bond. Put here is H, here is H. This is the answer. This is what generally in JEE mains they may give you organic chemistry. You can say it's a completely alkyl halides followed by as a preparation of alkene. So organic chemistry is always interrogated, children. So I hope you understand the class and study well, practice more number of problems. So we'll meet in the next class. So thank you so much.